Hello everyone. Today we're going to be making salicylamide from salicylic acid. I just wanted to go over the mechanism for this reaction because it's not a common one that you usually hear about in textbooks or anything, and so I thought it was pretty cool. So we're going to be forming an amide from urea and salicylic acid. So to do that, the salicylic acid is going to react with boric acid to give, oh, that should have an OH there. And then you're going to have the negatively charged carboxylic acid group because it's lost a hydrogen to the boric acid because the boric acid acts as the catalyst. And now urea under high temperatures forms ammonium cyanate. So I'll just draw it like this. There's a resonance structure for it, but it'll be in the link in the description if you're curious about that. So then this oxygen is going to attack the carbon here, and it's going to push one of its electrons into the nitrogen, and you're going to get this crazy looking, like, kind of looks like acetic anhydride, right? But instead of having another OH at the end, it's got the N and it's negative. So now there's a bunch of weird proton transfers. So electron transfers. So you go here, and then these electrons go to the nitrogen, and then the nitrogen comes all the way around like this and attacks what used to be the carboxylic acid. And that forms that. So the nitrogen still needs an extra proton, so hydrogen, in the form of hydrogen most likely. So that's where our boric acid catalyst comes back, because it has this positive water molecule on it. So it goes like that, and that forms our stable salicylamide molecule. And there we go. So I'm going to go and show you the reaction now. Okay, so in this flask here, we have 25 grams of salicylic acid, 1.5 grams of boric acid catalyst, and 35 grams of urea. So we're going to heat this until it becomes a liquid melt, and then we're going to heat it at around 180 degrees Celsius for 2 hours. So it could be plus or minus 10 degrees, but you want to keep it around 180. So we're going to turn on the heat, and we're going to let it melt. So it's going to turn into like a molten liquid, and then once that happens, we're going to try and keep it at a constant temperature. So I'll show you once it melts. As you can see, everything is now melted, and there's been a color change from a clear liquid to a slightly yellow color. I think that may be due to the cyanate ion that's produced, or cyanate molecule, it's not an ion, but that may be due to the color change. But anyways, as you can see, we're around 183 degrees Celsius, and the solution is effervescing some ammonia gas. So we're going to keep it here for another 2 hours, and once that's done, we'll add 100 milliliters of distilled water and 10 milliliters of ammonia hydroxide solution, that's 10% by volume, and we will mix that thoroughly and then boil it for another 5 minutes. So I'm going to let this heat, and I'll get back to you once it's done. Okay, so as we can see, the solution has actually become a very bright orange color, which is very pretty. So I let the solution cool down for a little bit, and now I'm going to add a solution of 100 milliliters of distilled water and 10 milliliters of 10% ammonia hydroxide solution. So now we place the solution back on the hot plate for around 5 minutes, and while this is heating back up, we can make a solution of 75 milliliters of 31.5% hydrochloric acid. We can now pour out the 75 milliliters of hydrochloric acid. I'm using a beaker. Remember always to wear proper PPE when you are working with hydrochloric acid, especially such one that's very concentrated, as it fumes. And if you can see that, this beaker is fuming, but I don't think you're going to be able to see that on the tape, which sucks, but whatever. So now that we have that, I'm going to wait for the solution to heat for a little longer and then cool down, and we're going to add it now. Okay, so now we let the solution cool down for a minute, and now we're going to add the acid in small portions. And if you can see, there's a little bit of a precipitation when the acid hits the solution, and once we add enough, we will get a cloudy precipitate crashing out. Look at that. Stir it around a little bit. And there we go. So as you can see, our end product, some nice pink crystals, kind of thick and fluffy like cheese. And now the next thing we're gonna do is pass it through a coffee filter attached to a beaker, and to collect the crystals and then let them dry. These are our crude crystals, obviously. We need to still perform a recrystallization to obviously purify them. There could be some contaminants like urea or boric acid or something like that within them. So we're gonna pass it through the filter, and then we're gonna let it dry to determine how much we have, because we need to calculate how much water we need to use for the recryst. All right, so once this cools down a bit, I'll pass it through. So now we're going to pass the salicylamide through a coffee filter. As you can see, there's a lot, so it's being a little difficult to get out. If it's being a little difficult, we can wash the flask with some distilled water. Make sure it's at least room temperature or cold, as salicylamide is pretty insoluble in room temperature and cold water. So there we go. That's a lot of salicylamide. I'm gonna wash it one more time. I'm gonna wash the beaker one more time. So as you can see, when I stir it, nothing really dissolves, it just becomes cloudy. The particles just kind of float. Oh, and I spilled it over. Nice. Oh well. Oh, one more peripheral washing. And now we're going to let this just kind of chill for a minute and let all the water drop out by gravity. Obviously, it's a gravity filtration. And then we're going to put it on a drying rack, which is just a paper plate with some paper towels on top to dry it more thoroughly. Okay, so I'm going to set that up. So here we have it. The salicylamide's now spread out on a plate that has some paper towel on top of it, and we just place the filter paper with the salicylamide on top. We spread it out a little bit so it has more surface area with the filter paper, so more water can get wicked away. And now we just wait until it dries. So as you can see, the powder was dried, and we got about 12 grams of crude salicylamide, and we put it in 350 milliliters of distilled water, and now we're going to recrystallize it. As you can see, it doesn't really dissolve at room temperature in water, So we're going to heat this solution up nice and hot, and once everything dissolves, we will wait for it to recrystallize, and then we can filter off the freshly more pure crystals. So as you can see, the solution was heated for about 20 minutes, and after it reached a sufficient temperature, everything dissolved into solution, and the water has taken on a yellowish color. But as you can see, there's some flecks of stuff, if I turn off the stirring, that are not dissolving into solution. So to fix this, we're just going to do a hot filtration into a beaker to get rid of those flecks of stuff. And I'm going to set up the filter to go about that, and we'll do that. So the solution was passed through a coffee filter, and as you can see, there were some little black flecks of stuff that got caught, and those were the things that weren't dissolving. And now we're going to let this solution, which is currently smoking because of how hot it is, cool down to room temperature, and then I'm going to put it in the fridge and let it cool down even more so all the salicylamide precipitates out of solution. So as we can see, the solution has crystals all floating around inside of it as they're precipitating out of the solution. I think the small crystals are basically less dense than water, so they form at the top, and then as more crystals solidify and like nucleate, because they serve as a nucleation point, they become denser than water, and then they sink to the bottom like that, which is pretty interesting. So, oh wow, look at that one. That's a huge sheet. And then, yeah, so now we're gonna put this in the freezer for a couple of minutes and let it cool down to about 0 degrees Celsius, maybe even let it freeze. And then it should let all the crystals precipitate out of solution. So after freezing the solution, this is what we got. And now we can just pass it through a coffee filter, and we'll have pure crystals. We're just gonna let them dry. So this is our end product after we recrystallize it and let it dry. As you can see, there's some very nice flaky pink crystals, which is indicative of salicylamide. I wish I had some better ways to test it, like a way to test the melting point or something, but we're just gonna wing it. So yeah, but our yield was terrible. It was around 50%. I don't quite understand why that is. I think maybe I needed to add more ammonia hydroxide solution after, like, when we just heated the melt. So I might run this again and see if I can optimize it at the numbers I was running it at to get a better yield. So we'll see. But thanks for watching. All references will be in the description, and have a good one.